We come to the last part of chapter 4, chemical bonding. In this part, we want to discuss about the first is the peculiar properties of water. The second is bonding and physical properties. The first, the peculiar properties of water. We want to discuss the enthalpy change of vaporization and boiling point of water. Water, the formula is H2O. Here we have oxygen in the molecule. Oxygen in the periodic table, I cut the periodic table only the right part of the table. Here we have oxygen, sulfur, selenium, tellurium, and so forth. Here we want to compare the boiling point of 4 compounds of group 6 or 16, group 6A or 16. Oxygen, sulfur, selenium, and tellurium. The hydride is H2O, H2S, H2SE, H2Ge. Here, if we notice that the position of oxygen is at the top of group 6A or group 16, so the number of electron is the lowest or the smallest. If we consider the intermolecular forces of van der Waals, oxygen with the lowest number of electron compared to sulfur and then selenium and tellurium, then the H2O should be the lowest boiling point, but that's not the fact. The fact is that H2O has the highest. This phenomenon can only explained by the hydrogen bonding presence in the H2O molecule. The second part of the peculiar of H2O molecule is the surface tension and viscosity. Water has high surface tension and high viscosity. High viscosity because the hydrogen bonding reduces the ability of water molecules to slide over each other. And high surface tension because the hydrogen bonds in water exert a significant downward force at the surface of the liquid. The third, ice is less dense than water. Most solids are denser than their liquids due to the molecules more closely packed in the solid state, but that's not the case for the water. In liquid water, hydrogen bonds constantly break and reform. And in ice, stable hydrogen bonding hold molecule part that make the ice less dense than water. And then the second topic we want to discuss is the bonding and physical properties. The first, the physical state at room temperature and pressure. For ionic compounds, there are strong electrostatic force or ionic bond holding the positive and negative ions together. So the ions are regularly arranged in a lattice with the oppositely charged ions close to each other. Then the result is high melting point and high boiling point, high enthalpy change of vaporization. For metals, apart from mercury, are solids. Most metals have high melting points, high boiling points, and high enthalpy change of vaporization. This is because it takes a lot of energy to overcome the strong attractive force between the positive ions and the sea of delocalized electrons. For covalent compounds consist of simple molecular structure. For example, water and ammonia, the forces between the molecules are weak, usually gases or liquids. So this simple molecular structure with a state of gases and liquid have low boiling point, low melting point, and low enthalpy change of vaporization. For the solid ones, the van der Waals forces are considerable, lower than ionic compounds or metals. Solubility, the first for ionic compounds, most of the ionic compounds are soluble in water. This is because water molecules polar attracted to the ions on the surface of the ionic solid. This chemical bonding between the polar molecules of water and the ions we call as ion dipole attractions. This ion dipole attraction replaces the electrostatic forces between the ions. So the ions go into solution. The solubility of metals. Metals do not dissolve in water. Somehow, some metals, for example sodium and calcium, react with water because these metals are too reactive. For covalent compounds, some are insoluble in water. That's the covalent nonpolar, such as iodine, I2. I2 we can dissolve in water using I- aqueous to form I3- aqueous. So here we have a solution of I2 in I-. When we mix with CCl4, here the colorless, CCl4 is a non-polar. When we mix these two immiscible liquid, then after some time the I2 will dissolve in CCl4. because I2 is nonpolar and CCl4 is also nonpolar. And the color is turn here, the color turn purple. The color of I2 in CCl4 is purple. The color of I2 in water is brown. So here the iodine move from the water to the CCl4. So here the upper part after the mixing, that's the polar H2O. The I2 move to the CCl4 and dissolve in CCl4 gives a color of purple. Some covalent compounds are soluble in water. This is for the polar covalent compound because hydrogen bonds form with the water molecule. For example, ethanol. This is the ethanol. Here the ethanol, and then here water. So between oxygen of ethanol, which is very electronegative, the oxygen, and then the oxygen bond with H, so there is a hydrogen bond between O of ethanol and H of water. That's why ethanol dissolve in water. And some react with water. For example, HCl and silicon tetrachloride. And the reaction with water we name as hydrolysis reaction. This is the equation of silicon tetrachloride and water produce silicon dioxide and HCl. And this is the reaction of HCl gas and water molecule liquid to form Cl- aqueous and H3O plus aqueous. HCl gas we name as hydrogen chloride. After dissolved in water, produces Cl- ion and H plus ion. This is H3O plus is H2O with H plus ion attached in it. Then the name of the substance we call as hydrochloric acid. The last, electrical conductivity for ionic compound, poor in solids because the positive and negatively charged ions closely packed together. They cannot move, just vibrate. But good in molten because the ions in molten can move freely. For metals are good electrical conductivity because there are delocalized electrons in metallic bonding with the positive ions of the metals. So metals, both in solid and molten, are good electrical conductor. The third, for covalent compounds, the electrical conductivity are poor.